Hey everybody, welcome back to Vibe Code Camp. I'm Paul Wakeham, and in this video, our third part of the series, we're going to go over what is arguably the most important concept that we're going to cover throughout this entire series. And that is the idea of context engineering. And if you're not familiar, the idea of context in AI is what is inside of the AI's brain is known as the context. So when you start a new chat with ChatGPT, what you're doing is you're clearing ChatGPT's brain. It doesn't know, for all intents and purposes, what you've previously talked to it about. Now, OpenAI, to make it feel more personal, has recently added memory so that it remembers my name is Paul and various facts about me whenever I start a new conversation. But generally speaking, ChatGPT and all of these AIs have no idea what you've previously talked to them about, and especially the AIs inside of these coding applications like Cursor and Claude Code. So we can't have them build an entire application inside of one single chat. We have to clear the chat with that /clear command. We have to start new chats. And each time we do that, you can think of it like the AI completely forgets what we previously worked on, how the project is structured, and all of the details. So how we warm it up and inform it of what we're working on is called context engineering. And that is, how do we make sure that what's inside of its brain is all of the right information and nothing else, so that it can build the feature that we want it to build, or it can fix the bug that we want it to fix, or it can do the thing that we want it to do. That engineering of the context, that finagling of what's inside its brain, is a very important process that, if it's done correctly, the results are 10 times better than if it's done incorrectly. I'm sure that you've seen people on YouTube and on Twitter that have said, I wrote one prompt and I got this app that makes me X dollars a month from this single prompt, and look at how smart the AI is. That has not been my experience whatsoever. And ever since this idea of context engineering came out, it was like, aha, someone is saying what I have been thinking. And you can look up a bunch of YouTube videos about this idea of context engineering, but I'm a very strong believer in this concept because it is the only way that I have been able, as a non-developer, to get these AIs to do what I want them to do and build what I want them to build, and have production-ready code that's ready for users to actually go out and put their hands on and interact with. So what we're going to go over in this video is, how do we engineer the context? How do we put the right stuff and nothing else inside of Claude Code's brain? And this is going to set the foundation for how we communicate with Claude and the other AIs for the rest of this project. So let's get started. So when it comes to Claude 4 Sonnet, the AI model that primarily writes all of the code for us, it can remember and it can think of approximately 1 million words at a time. That is 1 million tokens. But a token is technically not a single word. The word "the" is one token, but the word Mississippi may be 2 or 3 tokens. So on average, people say a single token is 75% of one word. So you can think of Claude Code's or Claude Sonnet's context window as being able to know about and think about 750,000 to 1 million words at a time. And believe it or not, as many words as that sounds like, that is not enough for it to build an entire application in one message or one shot, as people say. So the first step of engineering the context whenever we're in a new chat with Claude Code is the research stage. And the research, we can see here, takes up a really significant part of Claude Code's context window. Upwards of 15 or 20% is dedicated to research. Now, research you can think of as looking at the existing code and familiarizing itself with the other backend code that has to do with the backend thing that we're trying to implement, or the APIs that are already implemented on the front end that communicate with the back end, and making sure that the new APIs that we create are in the same style as the existing APIs. You can also think of research as using the internet to go out and find documentation about the feature or the software that we're trying to interface with, and informing the AI of how to properly use that software to do what we need it to do. It's just going out and finding all of the information it needs to do the thing that we need it to do, to familiarize itself so that it can actually do the right stuff and pull whatever in our brains out and into code and in front of us on the screen. Once the research is done and we're confident that Claude and the other AIs know exactly what we're going to do and how we're going to do it, they have all of the knowledge, then what we need to do is put that into a succinct plan. And that's where the next step comes in, which is the planning phase. And planning, you can think of like taking all of the research, everything it knows about the project, and everything it knows about the documentation for the software that we're going to interface with, and putting all of that into what I like to call a phase-based, step-by-step plan, where there are sub-steps under each phase. So what I do to get that plan is I tell Claude Code, hey, I need you to go out and create a plan. And in this case, I'll use Claude 4.1 Opus to do the planning. It's the smarter model, it's the better model, and it's specifically made inside Claude Code to do the planning. So it'll take all of the research, it'll take all of the information, and it will create a plan. And that plan will sit inside of its brain. All the steps of what need to be done at each phase to do the thing that we need it to do. But there's a key part here that I also tell it to do. I tell it to create a document inside of the documentation folder inside of our project. So when I do that, I'm telling it to take its plan that it's come up with and put it inside of the project, with, for all intents and purposes, is outside of its context window. And this is super important. I tell it to do that so that the next time we start a new instance of Claude Code, or we clear the memory, we don't have to go back through this research phase. We don't have to do all of the work. We can just point that Claude at the plan that we've already created with the previous version of Claude. And we can say, look at what we've done, look at where we're going, and look at the thing that is next on the plan to keep everybody on the same page. This is super important because you don't want to have the plan just sitting inside of a single Claude's context window if you think that the thing that you're asking Claude Code to do is outside of the scope of a single chat, a single context window. You want that to persist outside of the context window. And that's why we create this planning markdown document. And I don't write that. I have the AI write that and create that document inside of the documentation folder for me. So you can see here that the research and the planning phase take up about 30, maybe 35% of the context window. And that's all right, because this is the most important stage of the entire process. If you build a foundation that is crappy and the AI doesn't know the project structure, it doesn't know the documentation, it hasn't gone through all of the research, and it doesn't have a clear plan of what's going to happen first, what's going to happen second, and what's going to happen third, and so on, the stages where they actually go out and do the work, they're not going to be good, and it's going to come up with code that has bugs and doesn't interact with our system correctly. So it's okay to take up a significant part of the context window with the research and the planning stages. The next stage is the implementation. And in this implementation stage, this is where Claude will actually go out and it will write the code based on the research and based on the stage of the plan that we're telling it to work on. And then once the code is written, I tell Claude, hey, go and update the planning document with what has just been done. So the implementation is a very small piece of this entire process. It should take up a smaller piece of the context window than even the planning stage. So with the implementation done and the planning document updated, the next step is the testing phase. And testing is exactly what it sounds like. It's writing tests to test that the code that was just written in the implementation or implemented actually works. And if it doesn't work, then that means that the research and the planning and the implementation, all of these things that build on one another, was done incorrectly. And quite honestly, I'm sure that we'll see this in the project, I will run a couple tests and I'll ask it to make some fixes based on the results from those tests. Maybe a test fails for some reason. I'll do that maybe 1 or 2 or 3 times, and then I'll tell it, okay, scrap everything, go back to the previous commit, and we're going to completely start over. Because if a test fails, it means that one of these stages wasn't done correctly. And the AIs aren't great at knowing, this is what I did, now let me go back and figure out what I did incorrectly and fix that. It's much easier to, as a human, understand what the issue was, and then go back and restart the entire process over and put what we know was the issue into the research and into the planning. That way it comes out in the implementation and it doesn't fail the test whenever we finally make it to the testing stage. So what I'll do is, in addition to updating the planning document with the plan and the implementation, I'll also update the planning document with the test results. That way, if I need to start over, I can go to the new Claude and say, hey, here's the plan that my team and I had previously tried for this. It didn't work. Here are the results from the test, and here's all the information that we tried. And that will be in its research step. So before we wrap this up, I want to make it very clear that here we have 50% of the context window that is still open. There's nothing in here. We've used maybe 500,000 tokens throughout this process. And that's the right thing to do. We don't want to totally fill Claude's context window. We don't want it to look like this. Because the second that we try to do the implementation and then test and it fails, and then do the implementation again and then it tests and it fails, we're just compounding errors on top of one another, and the AIs just don't work that well whenever we try to do things that way. So we try to fill 40, maybe 50% of the context window with information about what we're trying to do, and if it doesn't work, we start over from the start with what we've learned as part of the research step. Now, something else I want to point out is the idea of sub-agents. And this, I'm sure, will come up in the next phases of the series of videos. And sub-agents have context windows just like the main Claude code that we talk to. But sub-agents have context windows that are specific to a very finite piece of the process. So what I like to use sub-agents for, and I don't use them as much as other people, but what I like to use sub-agents for is the research phase. I'll tell Claude Code, the main Claude Code over here, to set up a bunch of these sub-agents. And each of those sub-agents will go out and it will do a whole bunch of research. And maybe a sub-agent uses 20,000 tokens for its research. Maybe this sub-agent uses hundreds of thousands of tokens for its research, and this one does something similar. What we're doing, if this doesn't make sense, is we're spreading the research task across many millions of context window tokens by creating sub-agents. So what we then do, or Claude Code does for us automatically, is a sub-agent will transfer its context and what it learns back to the main Claude Code to enhance its research. So this way, this sub-agent learns something that is invaluable or something that is completely not valuable, but then it only brings back the invaluable information to Claude Code to use. And then this subagent does the same thing, and then this subagent does the same thing, and now the context window of the main Claude that's going to do the planning and then do the implementation and then do the testing, it has all of this really great information as determined by these subagents that have a single purpose, and that is going out and doing the research. Now, we can set up subagents to do a bunch of different things, but I really like using subagents specifically for research because it's such an important piece of this entire process. It is the foundation of this entire process. And if we tell a single Claude to go out and do the research, this research window may turn out to be humongous, and it could end up looking something like this. But with the subagents, it's confined. It has the purest, best information possible for doing the next steps of the process. So that's context engineering. That is the process of engineering the context that we give to Claude Code to do the thing that we need it to do, that we will rinse and repeat over and over and over again throughout this series of videos. I hope that makes sense. If you have any questions, send me a message or leave a comment. I also really encourage anyone interested in this idea to go watch all of the YouTube videos you can find, specifically about context engineering. They'll take the same concepts and almost the exact same diagrams that I have here and explain context engineering in a different way if my way doesn't make perfect sense. I think it's fascinating how to work with these AIs that don't have perfect memory or memory as big as a human's memory. And I think it's extremely fascinating that we as humans have figured out how to interact with these AIs to do the perfect thing and to produce the product that we want them to produce and have this repeatable process that works time and time again. So again, I hope that makes sense. If you have any questions, let me know.